Okay, this is a particularly ambitious agenda. I don't know what I was thinking. Um, but these are three important topics that the book unfortunately didn't really touch on too much. The book kind of touches on them a little bit later, but not in a way that I think is important. Those are dealing with files, and we've actually peeked at that a little bit. We're going to kind of go a little bit deeper into that, and then looking at a URL class, which actually there are two classes involved: a URI and URL. What's the difference? And then kind of how we can use that to read a text file or read basically do what they call screen scraping, kind of grab some stuff over the net and be able to use it. And what's one of the Java was one of the first. It was certainly the first major programming language to come out after the internet was big, and so right from the beginning they included the idea that you would be interacting with the network in some way. And that was, in other languages, you had to add on additional libraries and stuff. Okay, so basically files, the file object, which is actually just a fantastic thing in terms of dealing. The file objects allow you to interact with the local file system in a high level way. That's the idea, the high level way, instead of kind of dealing with bits and bytes, which for certain tasks you occasionally have to do, but the thing about this type of programming, object-oriented type of stuff, it's high level. It's higher level than a lot of, like if you're a C programmer, C was written for writing operating systems and compilers and things like that, and drivers, device drivers, very low level kind of. C is not really a high level language, a high level assembly language. What was fantastic about C is that it allowed you to kind of be more abstract in those sort of tasks. If we're in this arena, though, we are at a much higher level of abstraction. And so in almost all cases, you want to be working at that level of abstraction. That's where, a file object, that's an abstraction. A URL object, that's an abstraction. We're probably not going to get to regular expressions today, but we'll continue with that tomorrow. So anyway, okay, so file class, each file object refers to something on the file system. And so now, an object reference can either be instantiated or null. Those are the two possibilities. If I have a file reference, if I have an object reference, it's either refers to an actual object or it's null, which means it refers to nothing. Okay, that's one thing. But a file object can be non-null but refer to a file that doesn't exist. Okay, so that's kind of an orthogonal concept. In other words, if I have a file object, it might be null, because every object reference could be null, but the way we're going to be using it at first is going to be referring to an actual file, because we want to read. If we want to read a file, then it has to exist. You can't read a non-existent file. But why do you think it might be useful for a file object to be actually an actual object but refer to a non-existent file?
You can create that file later.
Yeah, exactly. What if I want to save a file, save some content? So think of like a Word document. When I create a new Word document, then it doesn't exist on the file system until I hit save. And of course, the save icon, of course, is like a 3.5-inch floppy disk image. When was the last time you used the 3.5-inch floppy disk? So, yeah, It's like the term "but dial." You know, okay, dial. Okay, where's the dial on your phone? You know, I don't have a dial on my phone. Or hang up. All these terms go, you know, anyway, just, okay. So there are three useful constructors for a file. We have one, a path name that's a string. So this is kind of where the thing is. And it can be relative or absolute. My experience has been that using relative path names is actually tends to be more robust. Why? Because supposing supposing you write a program where you're kind of referring to a file somewhere. If you have a relative, if you use it relatively, and that directory kind of exists on your computer, and I try to, if I clone your project and try to do that, then it will show up relative on mine. But if you use an absolute path, then it'll refer to your computer, and I don't have access to that. You know, so and the thing is that if you're working in a team and you're referring to things in an absolute form, then the other members of the team aren't going to be able to see that. So just that kind of comes up like in some of the sponsors that I write programs for, like they all tend to like to use absolute path names. So it's like, you know, they'll have something, this wasn't working, and here's what it was, and they're going to look, well, that's on your machine. I can't see what that is. Okay. Now the other, and this is where it's actually kind of neat. A file can actually refer to, I guess I don't say it here, but I'll say it verbally. A file can refer to either a file or a directory. So those are both actually, in your operating system, the difference between a file and a directory is actually a little bit vague. I'm not sure how they do it on Windows. I know that on Unix systems, of which Mac is one, they have these things called inodes, and it just, when you look at it at that level, you can't tell whether it's actually a file or a directory. But the file object knows whether it's a directory. In other words, a file object can refer to a file or it can refer to a directory. And so I can create, if I create a file this way, what this says is create a file of this name in this directory, which is kind of nice, because now I only need to specify the name of the file, and I can point directly to the directory that I want to create it in, instead of trying to have this big long string that has all the stuff in it. And then the other thing there, and I should probably have this somewhere, in general, regardless of which operating system you are on, it is, in Java at least, it is best to use the / as the path delimiter instead of the /, which Windows uses. I mean, that was kind of one of the dumbest things that Windows, well, it wasn't Windows' fault. It was actually, well, it was DOS's fault, and it wasn't DOS's fault. It was actually CP/M's fault, because DOS was ripped off from CP/M, and CP/M used the / for whatever reason. Again, it was not a smart decision. Why? Because the / is actually the escape operator. And so what that means is that if in a string, if you're on Windows and you want to refer to a path, you need to have a double /. Whereas Java, even at Windows or on any operating system, Java uses the /. And that's because Java was written on a Unix system, and so they pretended that everything was, was the way that God intended. Okay, so there are some very useful methods in the file. So even if I create a file using a relative path, and we'll show an example of this, it still knows where it is on the operating system. So I can get that. I can get the absolute path, either as a string or as a as a file, actually. I can test whether it exists, so that can be very helpful. If I'm reading a file, the first thing I want to know is, before I try to start reading it, I want to say, does it exist? The other place for this is that if I start writing a file, if I'm overwriting a file that already exists, then do you want to do that silently? Now, back in the original text editors, if you went to save over an existing file, it would just silently do that. And then after, you can imagine what happened. I mean, imagine like writing a Word document, and you go to save it on an existing file that you have other good stuff on. And do you want it to do that silently, or do you want it to say, hey, you're about to overwrite a file, do you really want to do that? You know, sometimes you do, sometimes you go, whoa. You can ask it, are you a directory or are you a file? So is directory, of course, is true if it's a directory, false if it's not, or is file. So it's going to be one of those two. And this is one of the other nice things, is that I can get the parent file. So once I've located a file, I can kind of start identifying where it is in the file system, so that if I want to read or write other things in that directory, I can kind of get them. And in fact, if it's a directory, I can actually get a list of all the files in that directory by a method called list files. And if I only want certain ones, I can actually filter them out. Maybe we'll see an example of this. So the file filter this is actually an interface, and there was some unfortunate naming because there are actually kind of two interfaces. There's one in I/O, Java I/O, that you can use with file objects, and there's another one in Swing that you use for when we deal with that. So that's a little unfortunate, but you just have to know which one. So for example, if I want to list all of the text files in a particular directory, I need to create a filter that says, okay, only look at the files like this. And that filter can use any criterion that you want. Okay, so let's look at some examples of this. Here, don't need you. Okay, so if you do a pull on the class code, there are some there's some stuff there. Let's make sure I got up to date here. Remote. Let's pull you. Okay, got everything. All right. Okay, so in the package called cs2173.io, okay, there's a class called read file, so that this is how we can read a file. Okay, and this is a pattern that I like for command line applications, where I want to read a file in. So typically, if there's just one thing. So first I say, well, did I put a file name on the command line? If I did, then the length of this args is going to be bigger than 0, and so args0 is going to be the file name that I'm going to use, and otherwise I'm going to give it a default. So in this case, there's a directory called input that is in there now, and then there's a file called 219-0.txt text file. Okay, so now I'm going to instantiate the file by passing it that file name, whether it's the default one or one on the command line. And now this is something which, again, in a command line application, you want to, if it doesn't exist, I'm going to say, okay, hey, you're trying to read from a file that doesn't exist, and then I'm just going to return. So now notice that if I have a method, this is sort of the little tangent here, is that if I have a method that where the return type is void, I can still just return with nothing if I want to kind of bump out in the middle. Normal for most normal, like in instance methods, you don't want to do that. Ideally, the best style for instance methods is to have one return at the very end of the method. It is possible to have multiple returns, but that can be very confusing, you know. But it's possible. It's not a mortal sin, but you know, it just easier to figure out what's going on if you just have one return. So this kind of violates that, but this is just a main method for, you know, and in that case, it's like, if I'm trying to read a file that doesn't exist, there's no point in even returning. The alternative would be to throw an exception. So I could throw a file not found exception or something like that, and that might be better, who knows. Okay, so here's the pattern for reading things that I've come to now. There are two competing principles here. One principle is the principle of variables having the smallest scope. So if I had my druthers, I would have scanner inside the try-catch scope. But the reason I don't do that is because I need to make sure that I close the scanner even if something has gone wrong. So stuff can go wrong when I'm reading a file. All kinds of things can go wrong. And if something goes wrong, I want to make sure that I close that, because now for a small application like this, it's not such a big deal. But the principle is, whenever your application uses a system resource, like a file, like in order to read this file, it had to kind of way under the hood. It's like opening the file up. And then if the program kind of bombs, depending on exactly how it's done that, you may leave that file open, and then that could lead to corruption. So I want to make sure that I close that file. And the only way to do it is using in the finally block. And the only way that the finally block can have access to the scanner is if it's defined outside the try block. So competing principles, but the principle of releasing system resources overrides the principle of minimal scope. So that a lot of programming is kind of weighing competing principles. Okay, so, and we've used the scanner before. It's like once we've created the scanner, like if you remember, we've done it using the command line with system_in. But what's nice about these, what that is that creates input streams, and so under the hood, it has created an input stream that's connected to the file. And so here we just kind of open the file, and then, like if we run this, then it's just going to kind of print out what was in that file. I mean, what was in it, is less important. Okay. Okay. Now, actually, as a second example, I want we talked about maps, and since they weren't on the exam, you probably kind of let them slide a little bit. But here's an example that builds a little bit on the previous one. So we're going to do the same thing. We're going to read a text file. And we have the same deal. It's like, okay, if it exists, if it doesn't exist, whatever. And in fact, actually, it's did I do it here? I don't think I did. It's also generally a good idea to just let. Okay, I didn't do it there. But here I'm saying, okay, this is the file we're actually using, and notice I'm getting the absolute path. So what I'm doing here, what I want to do here is, okay, I'm going to read a text file, and what I want to do is I want to get a list, I want to get a set of all of the words that start with each word, with each letter. Let me try to say that again. What I want is I want to find what are all the unique words that start with each letter. Okay, so, and for that task, what is useful, and just by the way, since they're going to be letters, let's keep them in sorted order. So to do that, I'm defining a sorted map in which the key is going to be a character, because that's going to be the character is a letter, and then the value is going to be a set of strings. And that set of strings are going to be for each character, are going to be all of the words that start with that character. Okay, so define it as a sorted map. I instantiate it as a tree map, and this is a useful pattern for doing this kind of thing. This is why these maps can be very, very useful. So beforehand, I don't know which characters are going to be there, and since Java is UTF, there are a bazillion UTF characters, and so I don't want to. I mean, I could, but what I could do is I could sort of say, okay, first I'm going to create one of these sets for every UTF character, and that would be kind of ridiculous. Instead, I only want to focus on the characters that are actually in the words in the file. So I don't know what they are. So here's how to do that task. So now what I'm going to do is, in the previous one I was just echoing the file, so I was reading it line by line. Here I want to read it word by word instead. So I want to read each word, and for each word, so I'm going to use has next, and so I'm going to it's going to be the while here. Grab the next word. Now, how can I figure out what the first letter is? Well, I can convert it to a char array and then pick off the 0th element. And that will always work because I'm always going to get an actual word, which is going to have at least one character in it. There are words with one character, but there's always going to be at least one. So this can always happen. And if you're worried about that, you could always wrap that in if char array length is bigger than 0, then kind of do this. But in general, this is a little dangerous because I may be getting an array of length 0, in which case there's going to be array index out of bounds exception, but that won't happen here because there's always going to be something there. Okay, so here's the little thing about dealing with maps in which I don't know what the keys are ahead of time. I first check, I say each map has a method called contains key. So if it does not contain the key of that first letter, then I'm going to put a new tree set in with the key of that being the first letter. So in other words, if it's not there, if this is the first time I'm encountering a word with that first letter, then I'm going to put that tree set in there. And what that means is that now when I get to here, when I get that first letter, that's going to give me a tree set corresponding to that first letter, and it's always going to be there because it was either a letter I previously encountered, or it's a brand new one. If it's a brand new one, I've just instantiated it, and then I'm going to add the word to that. That's basically what it is, and then I make sure to close it. And now here, let's sort of print each one. So I use the printf. You could do it with print line as well, but to be honest, I like printf because I have a lot more control over how the thing looks. Okay, so when I run that, and so it was pretty fast. So I get a bunch of stuff. So here, because the sorting of characters is done by UTF, then I have all the capital letters and then all the small letters. If I wanted to kind of fix that, then I could write a comparator that would do it the other way. But the other thing that kind of that this points out is that there are things that are words that aren't really words. So here's a word that starts with the character hash, the hash, and here's a word that starts with $, and here's a word that starts with ampersand, and then here are words that start with parentheses. Okay. So now if I'm writing, if I'm interested in processing this, what are things I might want to do? I might want to count the unique words. I mean, how many times does each particular word occur, for example? If I'm trying to do analyzing this thing. But then I notice that there's some garbage in here that I don't want to deal. In other words, all these sort of weird things aren't really these aren't really words. And in fact, there are some things where, let's see, where is it? Text can be kind of weird. So here are things that start with a capital I, and some of them are like I hyphen hyphen I, and then I hyphen hyphen haven't, and so in other words, there's in these words. I mean, if I'm trying to write something to try to analyze this in some way, there are these characters that I don't want to have to deal with, right? I mean, does that make sense? I mean, in other words, if what I'm trying to do is, let's say I'm trying to analyze this text in a very simple way, like just count the number of words, the times each word occurs. And I don't know what the words actually are, but if I try to do that with this, I'm going to get all this other garbage. And I'm going to get situations where some words, let's see, there was, here there's a word ebook and savages in brackets. So it's like somewhere else there's probably a word savages that's not in brackets, and this would treat them as two different words. So, okay. So now, how do I really? I want to kind of filter out that sort of stuff, and that's where these regular expressions that we'll talk about tomorrow come in. Okay. So. Okay, so that's reading files. Now writing files, that's a slightly different thing. When we start looking at user interfaces, let's see, I don't have it. I want to talk about URLs. So okay, so as this reading files, writing files, that's sort of a different matter. And again, a lot of the articles and content that you see operates at a low level, a byte level type of thing. And for writing files, it turns out that we can sort of take a file and then make a print stream out of it. Once we make a print stream, we can use all of our, we use system out printf or print line. We can apply all that sort of stuff to it. So if we're just doing text stuff, then you don't have to again go down to the byte level. That's okay. So those are files, but then what's kind of neat is that if we're processing a data stream and we know that it's text, when it comes to binary stuff, that's sort of a different matter. But if we know that it's text, then we can be actually somewhat indifferent as to whether it comes from the file system or whether it comes over the network or some other place. So now the URL class is, URL is kind of, the thing you type in. Now it turns out that actually that URL is a special case of what's called a URI, and we don't really, for this class, we don't really care about the differences. Like if probably in your network class, then the difference is important, but here it's less important. But a URL actually can represent something that's either local or it's over the internet, so you can kind of be agnostic to it. So now it turns out that there's this uniform resource identifier, of which a uniform resource locator is a specific example. And so Originally, Java, I think, just had the URL thing, and then at some point they realized it was like too restrictive, so then they kind of deprecated a lot of like you used to be able to just instantiate a URL and give it the string of the URL, but they deprecated that for good reason, and so now you create a URI and then you get the URL from the URI. So here's an example of that. So in a similar way as before, now I'm going to get the URL name from the from either the command line or here's a default one that's pointing to just one thing I like. There's a thing called Project Gutenberg. I don't know if you've heard of it. What they've done is they've taken a lot of novels and plays and other things that have gone into the public domain, and they've put it in on the internet, so anybody can you can read the entire works of Shakespeare without having to buy anything. So that's pretty cool. And they have a number of different formats, including a plain text one, which is actually this is actually pointing to. I forget what it's pointing to, but this is pointing to a particular one in text format. Now the thing about URI. So the first thing we're going to do is get a URI from that thing, and the tricky part there is that all of these there are only a certain number of correct things you can put in here. There are only a certain number of internet protocols, so HTTPS is one. File is actually another one, but you can FTP and others. So and then HTTP versus HTTPS. I mean, so these are all. You can't put an arbitrary thing here. So if I try to create a URI with an incorrect protocol, it's going to throw a malformed URL exception or malformed URI exception, URI syntax exception, actually. And then when I try to grab the URL, then that also kind of has, so there are these, when you're taking strings and trying to do these things, strings can just have any kind of garbage in them. So we want to make sure the garbage isn't in there. So the URI, we get the URL from the URI, and then what we can do is we can open a stream. And what's nice about this is, and in your other classes, if not this quarter at some point, you'll be kind of opening sockets and doing stuff. I mean, that's low-level sort of stuff. At the high level, once I get a connection to this, I can just kind of open the stream. All the low-level stuff gets taken care of underneath the hood. And so now, because Scanner has a constructor where the input is an input stream, which is this abstract stream of data, you're now agnostic as to whether that input stream is coming. You don't have no idea where that's coming from, and you don't care. So at this point, the scanner is just reading stuff from a string. And so if we have at least pointed to something which is, well, actually, regardless of what we point to, it's going to just kind of read it. And so we can read it, and we're just going to read it and print it. But there are all these, exceptions that we have to kind of worry about here. And then we also have to make sure we close the scanner. And closing the scanner also closes any input stream it has. In the other ones here, like when we open a file, when we point to a file under the hood, it was opening the file and creating an input stream from that file. That's why we had to worry about those exceptions. Anyway, so here, probably what I should probably print out what I actually get. Let's Let's see what we get here. Okay, so here we were using, okay, we noticed we got that, and it was Dracula. So just as before, we were, when you look at this, we're just kind of echoing this out, and as with the previous one that we had, because there's all this other stuff, and just even here, it's like, they put all these extra little characters in. Okay, so in other words, the lesson is that we can either be on the local file system, or we can be on the network, and then okay, and now all that leads to having to worry about all this sort of junk. So, like, remember, if we we're doing this. We encounter, kind of situations where words have extra little things in them. We have things that aren't even words. So how to deal with that? And that's what these regular expression things are about, which, as I predicted, I'm not going to entirely get to. And actually, the first use of that is there are two uses of regular expressions here. Now, actually, we could spend the whole quarter talking. Regular expressions are kind of a language in itself. It's actually a very weird language. So we're just going to dip our toe in enough to be useful for our purpose. Two main purposes. First one is actually a split approach, where if I and this is useful for things like reading a comma-separated file. You know what a comma-separated file is? Comma-separated value, CSV is. So those are sort of, it's like a spreadsheet-like thing, except that the delimiter is like a comma, and the delimiter can be anything that you want, but usually it's a comma. So if I read a string will just have all the sort of commas in there. And what if I have a string that has all these commas and I want to pick out the individual elements? Well, string has the ability to say, okay, I can pick out the comma and use that as the delimiter. In other words, split them based on that. But then for some CSV files, there's extra stuff in there, usually a space. So like a lot of times there'll be a comma and a space, or a comma and more than one space. And so when you try to just split on the comma, you get all these spaces in the individual strings, and you don't want that. And so it turns out we can use this regular expression that we'll talk more about tomorrow, to kind of say, all right, I can identify in a very expressive way, it's like a comma and one or more spaces on either side, for example, is how I can specify that. So, but that is all for tomorrow.